This is our latest tape drive technology. It includes all of our electronics and our bit detection intelligence inside of it, in addition to an RFID reader now. So everything is automatic. Essentially, when the operator wants to read a tape, take any tape with an RFID tag, load it into the drive by pushing it on the hub, close the door, press load. The drive will automatically find the edge of the tape, load it. After it tensions the tape, it'll actually go ahead and read it. I have a hardware debugging monitor over here on the other side, which you'll see in a few minutes, which will actually show it reading the data. And then there's a computer in the back there showing the status of the server capturing the data. The RFID tag and the data was sent to the server, so the server knows what tape it is. The operator does not have to enter or do anything. When the tape is finished, this is a very short tape. Some tapes have a minute of data. I'll call it a minute of runtime. Most have about 5-6 minutes. A few tapes, generally from the institutions, they run all the way to the end. They're about 15 minutes tops. This NASA tapes that I'm showing you here, they're generally fairly short, so they're about generally 5 minutes each. I'll take another one now. This tape here was from February 4th, 1967. The operator would then take another tape. This one here is actually Hurricane Inez on October 7th, 1966. Again, place the tape on the drive, RFID tag on it, press load. The drive will locate the tape. Feed it in. And it will start reading on its own. If it has a problem with any data, as you saw right now, it'll backspace and find out and figure out what the data is. In this case, it has corrected it. On my hardware status screen, which is something the operators don't see, it's showing a bunch of G's, that's good records across here. The computer in the back is showing the status for the drives, and it'll roll up and actually show us the records. And we can connect as many drives as we like to the server. Every drive has its own Ethernet connection, so they're just on their own local network. And they just spin and read tapes away, as you can see. This one here is probably at somewhere around 75 records already. Right about 100. No errors yet. This tape's they're generally about 300 to 700 records, which don't take very long. And this is a good example of what the Nimbus data is like for runtime. Right now the drive is trying to figure out a problem record there. You can put up the runtime hopefully in a counter in the corner of this video to show how long it's actually taking to do this. As you can see, there's nothing the operator has to do, so servicing 18 tape drives by one person is not a problem. They're just loading and unloading tapes as it needs. They don't have to even look at the tape, just push it in. And the tape is finished. It automatically rewinds the tape itself. It'll actually pull it right up through and eject it, and the operator can pick up the next tape and load it into the drive, and it's free to read another tape. And that's how automatic this system is now. To eliminate, well, to reduce as much as possible human error. We found with barcodes that operators could scan other things like alcohol bottles, drink bottles, just about anything that has a barcode on it. With RFID tag, we eliminated that possibility. So the detector actually detects the tape within 3 inches of the label and knows for certain that it's reading that tape. I'll open the tape up, show you what it is. This is, there you have it. This was an old Nimbus 2 tape. Orbit 1931, October 7th, 1966. In our lobby, I used this tape as an example because we actually have an image of it, and it's interesting to see the picture of the temperatures